a fully automated system that turns complex architectural geometry into build-ready construction data. The toolkit improves accuracy, speeds up production, and enables execution at a scale not possible with manual work. It supports thousands of unique facade elements, connecting design, fabrication, and construction. The process starts by creating accurate envelope geometry for each pod. The surface is panelized, structurally organized, and combined with a secondary steel framing system. Across the project, over 7,000 double-curve GRC panels are generated automatically. The automation toolkit is applied directly to the model. Stud frames, fixations, and structural elements are generated instantly across multiple panels. All layers, framing, brackets, connections, and panels are assembled automatically into a build-ready system. This level of automation replaces hours of manual coordination with real-time, rule-based generation. All elements shown are generated automatically by code, with no manual modeling involved. Parametric controls convert 3D geometry into fabrication drawings. By changing one value, the system outputs shop drawings for selected panel, one sheet per panel. This allows accurate documentation of thousands of unique elements without manual drafting. Here is an example of the fabrication drawings. The secondary steel layout is optimized to follow the curved facade geometry. Framing aligns directly with stud frames and brackets, removing unnecessary cantilevers and extra steel. This reduces material use while keeping the system clear and buildable. The result is a cleaner structure that is easier to fabricate, install, and maintain. A custom algorithm optimizes roof drainage across the canopy. Drainage points are adjusted to maintain a minimum 1% slope within distance and depth limits. This prevents water accumulation while avoiding clashes and excessive structural depth. The system automatically calculates optimal borehole positions based on geometry and construction constraints. The toolkit interface is flexible and can be reused or adapted for future projects. The digital system is verified through real construction on site. Automated logic developed in the model is successfully executed in reality. Thanks for watching.